in this question, we have two circles with centers O and P that have radii 2 and 4 respectively and are externally tangent. So again, like, tangent just means that like the circles are touching at one point. Like in this case, they're touching at that one point there. And we're given that points A and B on the circle with center O and points C and D on the circle with center P, such that AD and BC are common external tangents. And we want to know what is the area of the convex hexagon AOBCPD. So what we're given is that like this line here is this line and this line here, they're all tangent to the circle. So like that just means they just touch the circle at exactly one point. Like they just barely touch the circle. So the question says, what is the area of this concave hexagon, like OABCPD? So that's just like this hexagon here. This like weird shape here. I want to find the area of that shape. So the first thing to notice is that you can kind of like notice this hexagon, you can split it in half. You can notice that this hexagon is equivalent to two trapezoids, right? Or two of these blue quadrilaterals, right? So you can notice that this hexagon is just two blue quadrilaterals in this case. So essentially, if we can find the area of one of these blue quadrilaterals, then we can double our answer to get our final answer. So the idea is to notice, like this is tangent. So a very common important fact is like you have a circle and you have like a line. You have a line that's tangent to the circle. Then if you connect the center of the circle to the point of tangency, then you're going to get like a right angle. So this is a very like useful fact in geometry problems. So if we were to use that fact here, we said this line here is like tangent to this circle. So that tells us that when we draw this line here, it's going to be like perpendicular. So a very like important fact to know. So then like similarly, we have that like this angle here is also 90 degrees. So remember that like whenever we have like a line, in this case we have a line, and if we have two lines that are like parallel, or two lines that are perpendicular to the same line, then they must be like parallel, right? Like this is like a general fact. Like if you have like two parallel lines and like a line like that, then like you have like these two angles are always equal, like by parallel lines. So like this essentially tells us that like, OA or OB, so like this like green length, you have this green length here has to be parallel to this green length here. And similarly, like this green length here has to be parallel to like this green length here. So that's essentially telling us that we have like a trapezoid thing. So basically, we just need to find the area of a trapezoid, right? And we know how to find the area of a trapezoid. Like if we have a trapezoid, remember that the area of a trapezoid is you take like the two bases, you take the length of the two bases of the trapezoid, you take their average, and then you multiply by the height of the trapezoid. So that's how you like find the area of a trapezoid. And so we know that the radius of this circle here is like 2, right? So this is 2, 2. And we know the radius of the other circle is 4, 4. So we notice that we already know the two bases. They're 2 and 4. So all we have to do is like find what is this like length of this height here, right? So we just have to find like what is the length of this height here, and then we can find the area of the trapezoid. So to find the area of that, to find the length of that height, this is actually a very common configuration. So you'll actually see this a lot in math competitions. So this is good to like be familiar with. So like this length here, we know that it's a radius of the circle, right? So like this length here is going to be 2, and this length here is going to be 4, right? So this entire length here, 2 plus 4. If I do 2 plus 4, then this entire length here is going to be 6. The distance from O to P is going to have length 6. So the idea from here is like, it's a very common strategy. Imagine, so we know this radius is 4. So imagine if we were to like take this, and then we were to imagine like drawing this perpendicular line down here. So if we draw this like perpendicular line down, if this length is 2, this green length here is 2, then, by parallel lines, this length here is also 2. So, and we know this whole length was 4, right? Originally, the whole radius had length 4. So that tells us that this length here also has to have length 2, 4 minus 2, 2. So that length has 2. And now we can focus on like this yellow triangle here, this yellow triangle. And notice that we have like the hypotenuse, right? We have this length 6 here, and we have this length 2 here. So to find the height, if I call this like x, then by the Pythagorean theorem, I can say that x squared plus 2 squared equals 6 squared. So 6 squared is 36, 2 squared is 4, 36 minus 4 is 32. So x is equal to the square root of 32, which is equal to 4 square root 2. So 4 square root 2 represents like the height of this trapezoid. So we know that like the two bases of the trapezoid, right? The bases of the trapezoid are 2 and 4, right? We found that since those are the radii. So to find the area of the trapezoid, we always take the average of the bases. So 2 and 4, the average is 2 plus 4 over 2, which is 3. Then you multiply by the height, 4 root 2. So this is the area of just one trapezoid. So if we want to find the area of the hexagon, remember we said the area of the hexagon was just double the area of one of the trapezoids. So you would just multiply by 2, and you can get like 24 square root 2. And that would give you choice B, which is the right answer.